We are given that X is a finite dimensional linear space over a field K. Now what does this mean? Well, K is a field, meaning that elements in K can be either real or complex. We're also given that X is the span of the basis vectors E1 to ED. If you watched my previous video, you already know what a span is. But here's a quick recap. The vectors E1, E2, all the way to ED form a basis of X. These are standard basis vectors. The span of the set of the basis vectors simply means all possible linear combinations of these vectors. Thus, any vector x in big X can be written as x is equal to lambda 1 times E1 plus lambda 2 times E2 all the way up to lambda d times ED, where the lambda sub I are scalars in K, either real or complex numbers. Understanding the given norm. In the question, we are given that X has a norm where it is the max of the absolute value of the scalar lambda. This norm simply takes the largest absolute value of the scalars lambda that define X. Our goal is to prove that the norm we are given is actually valid by checking that it satisfies the four axioms. A function is a norm if it satisfies these four properties. We're going to go and prove each property. First, positive definiteness. Since we are taking the maximum absolute value of the lambdas, it is always non-negative. So the norm of X has to be positive or strictly greater than equal to 0. Moreover, the only way the norm of X is 0 is if all the lambdas are 0, which means that X has to be 0. So positive definiteness holds. Next, homogeneity. Scaling by some scalar mu. If we multiply X by scalar mu, we get mu of X is mu lambda 1 times E1 all the way up to mu lambda d times ED. Now we apply the norm definition to our scalar multiplied by X, and by factoring out the absolute value of mu, we get homogeneity, so it holds. The last one is the triangle inequality. Now let's take two elements from X, say X and Y, and we add them together and then apply the norm. And using the basic triangle inequality as shown here, we get this. But through some clever manipulations, and we also know that since this has to hold, we conclude that the norm of X plus Y is less than the norm of X plus the norm of Y. Therefore, the triangle inequality holds.